Hello and welcome to another Monday night Q&A. I'm joined tonight by my colleague Mark Barnes-Ryder from the technical help team. How was your Monday so far, Mark?
Yeah, very good, thanks, Sam. Yeah, but looking forward to the up and coming changes to the 18th.
Yeah.
Very good.
No, yeah, I think we all know it's just around the corner now. So interesting times ahead. Busy but interesting. This is the first live Q&A session for a little while, so I'll just run through a few house rules. We start off with our question of the week, which we posted it out across social media channels earlier today, and we'll go through our answer to that question. Then while you're putting your questions in the chat, we'll go through some questions we didn't get around to from previous Q&A sessions. So please start to post your questions into the chat, remembering that there's no such thing as a stupid question, only stupid answers. Please also remember to be respectful to each other in the chat, as the whole idea of this evening is that collectively we help each other with the aim of improving all of our collective knowledge and understanding of all things associated with 7671 and the world of electrical installation. So let's have a look at the question of the week this week. So it was a bit of a definitions question. The question was, what is defined as protection against electric shock under single fault conditions? And it was a little bit of a mixed bag in terms of the polls out there, in that we were getting about a 50-50 split between basic protection and fault protection, with a few people going for additional. But based on that definition, if we were to look into part two, our definitions, we would have been able to see quite nicely that fault protection is protection against electric shock under single fault conditions. And that's an interesting point, because sometimes when people see a requirement for fault protection, they then often get carried away with the what if situations, and it's not. We just need to think about single fault conditions. So not if, what if the protective device fails and the earth falls off and this and that those aren't what we consider to be fault protection. So fault protection is against a single fault condition, such as a short circuit, such as a line to earth fault. Just to finish things off, we'll go through some of the other definitions. Additional protection is a little bit interesting. There isn't actually a definition of additional protection in part 2 of 7671, but we have got section 415, which talks us through what additional protection is. We do have definitions for basic protection. So basic protection is protection against electric shock under fault-free conditions. So the way I was always told was that basic protection is to protect you against things that you touch that might be live, which should be live, i.e. live conductors. So and we used to refer to it as that was protecting you against direct contact, so touching something which should be live, like insulation would be a form of basic protection, whereas fault protection is protection against you touching something which could become live under a fault condition but shouldn't normally be live. So for example, the metal casing of an appliance shouldn't be live, but due to a fault within the appliance that may become live under fault conditions. So and again, we had a definition there that was referred to as indirect contact, in that you were touching something that was live which shouldn't have been live. And we do also in definitions have a definition for backup protection. Backup protection is protection by an overcurrent device coordinated with another overcurrent protective device in series. So a good example of backup protection may be where you've got prospective fault currents which are very high, perhaps 20k, 30k in an installation, and you want to use protective devices with a 10 kA rating, So you need an upstream device that will cope with that 20k or 30k fault, and while it's operating, while the fuse is blowing or the device is tripping, it's not going to let through enough energy to damage your downstream devices, i.e. your 10k rated devices. So that's what backup protection refers to. Anything you would add to those definition pieces, Mark?
Yeah, I think it should be remembered that the backup protection is where both devices operate together to provide that limiting of the energy let through, isn't it? You'd still need the upstream device to operate in conjunction with the downstream device to provide you with that quality of or that backup protection. And secondly, when we talk about fault protection, there's BS 7671 mentions two types of provision for protection. One is the basic provision, which consists of basic protection, I believe. But the one that we're talking about tonight is the fault protection that is actually an enhanced provision, because it includes fault protection and insulation of basic insulation of live parts. So that's if you want to look at the reg, guys, it's 410.3.2, and it will clear up what I'm talking about there.
Okay, we'll pick up a few questions from previous sessions as well. So one that came in was, can I still label or identify a particular socket outlet for a specific item of equipment and therefore not provide RCD protection for that socket outlet? So Mark, can we label socket outlet to exclude us from providing it with RCD protection anymore?
Generally speaking, you can't. No, I mean it was in the 17th edition, but it got taken out in the very last edition, the 2015 edition. And there's only one permitted exception now in the 18th, and that's where you've got for installations other than dwellings, you're allowed a risk assessment that can maybe justify that the RCD protection isn't necessary. But the designer should produce that risk assessment, and in our view, it needs to be really robust. So if ever it is relied upon in a court of law, that it'd have to be pretty watertight.
Yeah. So we would always, in those situations where you are using the risk assessment permitted exception, get to know the users of the installation, get the responsible person for site, so that they know, they can tell you how the installation will be used, who it will be used by, what are the potential hazards. But it's possible, if they can prove to you they've got safe systems of work. So for example, all items of equipment that are plugged in are regularly maintained and pat tested, that only they supervised people can plug items of equipment in, no personal items are allowed. So if they've got safe systems of work in place like that, it's possible. But yeah, you would always need to involve the responsible people from site to understand how those socket outlets are going to be used during normal operation, so that you can arrive at your outcome of risk assessment to say that there are enough safe measures in place to ensure that the additional protection of an RCD is not required.
Yeah, and don't forget, guys, and girls, that's just for non-domestic. So your commercial, your factories, and the like, and that's where you would need to really look at their internal systems, their health and safety operating procedures. On large non-domestic sites, that could be quite onerous.
Yeah, but like you say, you need to do it, don't you, Mark? Because once we walk away, we don't know how those socket outlets are going to be used, who's going to be using them, what they're going to be using them for. So that's why we need to involve the responsible people from site and get them involved in that risk assessment.
Yeah.
Okay, another RCD related question. Do the latest regulations require outdoor domestic lighting to be RCD protected? because the regulation talks about within household premises, and these lights will be on the outside. So this is something that we do get on the telephones a little while, and I think it's a bit of a misunderstanding. Because the lights are outside in a domestic installation, do I need RCD protection, Mark?
Well, it's interesting, isn't it? But I mean, the regulation talks about the circuit itself, doesn't it? The AC final circuit. It's not just about the luminaire. So we would say yes, it should have RCD protection. I mean, it is a dedicated reg in the 18th edition, as you said, Sam. So absolutely, yeah, RCD protection all day long.
Yeah, you're spot on. It's if you read that reg carefully, it does make it clear that it's the circuit supplying the luminaires that requires the RCD protection. It doesn't actually specify the luminaires themselves, as it does, for example, with socket outlets. So yeah, it's the circuit supplying the luminaires that needs the RCD protection. And one other one before we go into the chat room. So if the maximum permitted value of earth fault loop impedance for a circuit breaker is not given in table 41.3 of BS 7671, how can I calculate it? And I'm just going to show the viewers a slide. So there is a regulation 411.4.4 that says that the characteristics of a protective device, see regulation 411.4, and the circuit impedance shall fulfill the following requirements. So there's a relationship, ZS, the maximum ZS for the circuit multiplied by the current it would take to operate the protective device has to be equal to or less than UO, the nominal supply voltage to earth, multiplied by C min. So we do have to factor in the fact that our suppliers, our distribution network, can't always guarantee that we're going to have the nominal rated voltage, and it may fluctuate. So there is a formula which you can use. If we just rearrange that formula from the reg, you can see that the ZS has to be less than or equal to UO multiplied by C min divided by IA. So if we said single phase installation, UO is typically going to be 230, C min's 0.95, and then IA will be the rating of your protective device plus the factor, because it's a circuit breaker. So it'll be 5 times the rating for a type B, 10 times the rating for a type C, and 20 times the rating for a type D. And you can, if you've got spare minute, you can prove that formula by running it through, and that's how all the values in table 41.3 are arrived at. 41.2 for 0.4 of a second and 41.3 for 5 seconds. But you can also then use that same formula. So if you did have an odd value, like a 5 amp breaker, for example, then you could use that formula to calculate what the maximum ZS is going to be. So useful to know. Okay, we'll open up the chat room now and see what we've got. So thanks very much for those that are putting in the questions. It's very much appreciated. First one is a question, a bit of a comment. Do you think 10mm earth cable is a thing of the past, with plastic pipes feeding both gas and water? Yeah, that's very much in the domestic market. We're seeing now that our utility services are entering the property in plastic pipework, and then often changing to metallic within the property for aesthetic reasons. But don't forget, we're not just domestic, are we, as our electricians? So when we go outside of domestic, we'll start to see other extraneous conductive parts, such as structural steel, start to be involved, and that will need bonding because that's not going to be plastic. So yeah, no, I think in domestic, yes, there's a move away from requiring the bonding of those incoming service pipes, but there can still quite often be other extraneous conductive parts that are going to need bonding. Would you add anything to that, Mark?
Yeah, I mean, certainly in the case of the water service, that's almost certainly going to be plastic these days. The gas is still a bit. I've not really come across any plastic gas service pipes myself, and you would need to really doubly check with the gas installation in the case of a new build. But and as you say, there's other extraneous conductive parts. For example, if you've got decorative metallic waste pipes on sinks and things that and on baths, and if you've got your cast iron baths as well, so there's lots of things that can be still extraneous and conductive.
So yeah, we're seeing it less and less used in domestic, but outside of that, we're still going to need to bond our extraneous conductive parts. Another question that's come into the chat. I was taught to measure R1 plus R2, then measure ZE to arrive at ZS. However, I've come across people who do ZS and then deduct ZE to arrive at R1 plus R2. You obviously aren't checking the continuity of the conductors on a ring, but why shouldn't this be done on a radial? It shouldn't be done. That's the first thing to say. We can calculate a value of ZS from measured values of ZE and R1 plus R2, but we can't do it the other way around. We can't arrive at a value for R1 and R2 by measuring ZS and deducting a measured ZE. And the reason being is that part of our initial verification, we have to verify a protective conductor for our circuit. Now we do that either by R2 direct or R1 plus R2. We have to do that then to verify that we have got a circuit protective conductor for our circuit. We can't do it by an inferred calculation of ZS minus ZE, because ZS might be benefiting from, for example, parallel paths, and so we're getting an unclear picture of what our earth fault path for the circuit is, and we also haven't verified that the circuit itself has a dedicated protective conductor. We can see that there's a fault path there because we've got a ZS, but it may be a fortuitous fault path that we might not be able to guarantee in fault conditions. So we should always be confirming that we've got a dedicated circuit protective conductor, either R2 or R1 plus R2 first, before we're doing those live measurements of ZS and ZE. Would you agree with that, Mark?
Yeah, absolutely. And on top of all of that, there's a dedicated reg, 643.2.1 that says the conductive parts, if any, shall be verified by measurement of resistance on protective conductors, including protective bonding conductors, and in the case of ring final circuits, they're live conductors as well. But in this instance, we are talking we're talking both actually. So there you have it. 643.2.1 says it shall be verified by measurement.
Yeah. So yeah, it's a common one, and we do hear a lot of people noticing it, and we do see it on assessment where we're presented with a lovely certificate where the ZS's match perfectly, the calculation to your ZE plus R1 plus R2, and it does look a bit suspicious, and when people are asked to measure, there's clearly some calculations going on which shouldn't be being carried out. We need to measure R2 or R1 plus R2 independently. Okay, we've got.
Yeah, I think it might be worth saying, Sam, that when you are carrying out the ZS test, that predominantly your measured value of ZS should be lower than your calculated value, because your calculated value doesn't take into account any parallel paths that are going to be evident when you're carrying out that ZS test, if you're carrying it out live.
Yeah, absolutely. Okay. Got a question there that's a carryover, I think, from last week. It says, have you addressed the iffy question of the week from 4 days ago? Which of the following operating characteristics for a device protecting a conductor? Yeah, we did get a lot of people got a bit bent out of shape about last week's question of the week. If we haven't posted the answers, we will do. I think we certainly aimed to post them at the back end of last week. The main point of consternation was caused by a lot of people slightly misreading the answer A, and that was the relationship between the rating of the protective device, IN, the nominal rating of the protective device, and IB, the design current, because the option that was given was IN has to be greater than IB. And it's a subtle difference, but it doesn't have to be greater than IB. It can be equal to IB as well. So a lot of people were saying there were two correct answers when in fact there weren't. Answer A, which said that IB has to be greater than IN, was not strictly correct. So I think that caused the little bit of confusion. But if we haven't posted it out at the back end of last week, we'll certainly post out the correct answer this week. Okay. Hi, recent EICR for one flat in a block, consumer unit approximately 20 metres from the meter, fed in 3-core SWA but no switch fuse fitted after the meter. What code would you recommend? So this is the situation where from the sound of it, the tails supplying the consumer unit are more than 3 metres in length, and therefore we're relying on the overcurrent protective device in the service head to provide protection for those tails, and experience and the regs tell us that we can only do that if we stay within 2 to 3 metres of the service head, because outside of that then the DNO will not guarantee that you can use their protective device for protection of your extended tails. When it comes to an EICR, I think there's a few things that you need to look at. First of all, you need to make sure that visually, if you can, inspect those tails along their length, that they're not showing any signs of damage due to mechanical impact. Providing they're not showing any signs of damage and you can measure that they can meet the ZS of the overcurrent protective device in the service head, so the ZS is providing fault protection for them, then that's a tick. And then if you can confirm that if you've got fault protection, you've also got tails that are undamaged, tails that are either in a wiring system or in containment that's suitable for the environment that they've been installed in, then we would suggest it's just a C3, in that it's not unsafe, but strictly speaking they haven't complied with the regs unless you've got documented evidence that says you've got permission from the DNO to use their protective device for your extended tails. Obviously if you can't meet the ZS because you're a long way away and you've got small tail CSA, then that would be considered a C2. If the cables aren't adequately protected or suitable for the environment and they're showing signs of damage, so now you can see the sheath of cable damaged and you can see the conductors underneath, then again, if that can be touched, that we'd consider a C2. But if everything's okay with the cable and you can meet the ZS, we'd only suggest a C3. Would you add anything to that, Mark?
Yeah, I think I think you said it all. I think the key there is if you can meet the circuit ZS for the protected device and there's no obvious damage to the cables, then a justifiable C3 in our view. I mean, you'll soon get an idea. For cables that have been installed for many years, you should be able to use your engineering judgment on what's the likelihood of those cables becoming damaged moving forward if they've been in for sort of 20 odd years and nothing's ever happened to them. So but I think the key there is that visual damage and looking for any of that, and the maximum ZS, if that can be complied with, then Absolutely, because don't forget the condition report is based on electrical safety. So if you can prove it by visual inspection and by testing that it's not electrically unsafe, then you're generally left with your C3s if it requires improvement.
Yeah. We've had an engineer put a comment in. I guess this is talking to about our risk assessment. Don't we still carry the risk as soon as we are off site? We can't police it. I think we understand what you're saying, but this is where if you don't know the installation, you don't know how the electrical installation's being used, then strictly speaking, you're not the right person to be able to do a risk assessment in that environment. So this is where we were recommending that always involve a responsible person for the site, who's got health and safety knowledge and has got knowledge of how the installation is going to be used, so that they can, with you, produce an effective risk assessment to see if RCD protection can be exempted. With Amendment 2 coming out, does this mean we will need to take the exam even if we already have passed the 18th? Although Amendment 2 is going to result in a new book, it's not considered a new exam, if you like, from our qualification bodies, City and Guilds, EAL, etc. So it will still be an 18th edition qualification, and there will, as far as sort of EAS requirements, it's not considered a change to the regs, although it is obviously an update and a new edition. So the requirements to update, I mean, we would always recommend, but it's not a requirement in terms of EAS terms for you to need to maintain, for example, QS status. Let's have a look, see what else we can pick out. When the maximum permitted ZS value is exceeded during a live test with RCD protection, let me read that again. When the maximum permitted ZS value is exceeded during a live test, will RCD protection be sufficient for fault protection, and is a risk assessment needed to allow the RCD to provide fault protection? So it's a good question, and it's a common question that we get on the technical helpline. The first thing I think we always ask is, well, why is the ZS high? Is it reasonable? Does the ZS that you're measuring reflect the cable size and the length of run? So we always recommend doing a sanity check on that ZS measurement. Can you compare it to what it was if you've got access to previous certificates or condition reports? But certainly do a sanity check first to say, okay, that's why that ZS value is high. If it is high, then yes, you can rely on an RCD or the RCD side of an RCBO for fault protection. But you would want to be able to confirm to yourself first of all that it is a valid measurement of ZS, and it's not a high measurement which perhaps might indicate a damaged cable or a faulty circuit in some way, which then might continue to increase, and so eventually may even go outside of the characteristics for an RCD to operate safely. But strictly speaking, yes, we can use an RCD for fault protection, but you've got to do that sanity check to yourself and say, well, why is that ZS that high? Can I justify it? So do I believe it's a stable situation, and therefore my RCD is going to continue to provide adequate fault protection? Again, would you agree? I mean, it is a common question we get, isn't it, Mark, on the helpline?
It is, yeah. I mean, it's Regulation 415.1.2, which says it, the use of RCD is not recognised as the sole means of protection, but we do say that it can be used. And as Sam says, that you've got to be careful depending on the level of fault current that RCD will work before it becomes unserviceable, because, as I say, depending on the level of potential fault current there. So Absolutely, it can, and we do rely on it quite commonly throughout installations. I've worked on older installations, older submains, when it was perhaps incorrectly sized, and the only way I could get around that was by putting an RCD at the front end of that circuit. Otherwise, it meant digging sort of 50 metres of trench to replace the cable. So there has to be an element of practicality in all of this, but you do have to do your sanity checks, as Sam says.
Okay. Again, a follow-up from one of the engineers has said we can calculate ZS by adding R1 plus R2 to ZE. Yes, absolutely. So if you've got measured values of R1 plus R2 and measured values of ZE, it's perfectly acceptable to calculate ZS. So yes, that is okay. I think what the previous question was referring to were people were concerned that they were taking measured values of ZS and measured values of ZE and calculating R1 plus R2, which is not acceptable because it hasn't confirmed that the circuit has an adequate protective conductor. So yeah, calculations of ZS by the addition of a measured R1 plus R2 and a measured ZE, perfectly acceptable. But calculated values of R1 plus R2 by subtracting ZE from ZS, not acceptable. Okay.
Yeah. Can I just add to that, Sam?
Yeah, sure.
We do see certificates coming in where it looks like the ZS has been measured, and if you could declare that on your install certs and even on your condition reports, that would help whoever's looking at that condition report or installation cert to know that actually you've calculated ZS, and that can go a long way to proving your schedule of test results.
Yeah, absolutely. The question about do we know if AFDDs are going to be becoming mandatory within the domestic sector, and how long do you think it will be till the cost of products will be reasonable? We don't know. We, as everyone, are waiting with bated breath for it's now only a matter of 4 weeks away. I think today, in 4 weeks' time, Amendment 2 will be published and available to all. So we're waiting. I think if we go by the comments, the AFDDs were one of the most heavily commented on sections of the document for public comment, and there was a lot of requests for it not to be mandated throughout, so we're just waiting to see what the final outcome is. But yes, we like everybody else are waiting, and it is only 4 weeks away now, so interesting month coming up, certainly. I've got someone saying that they don't agree. I'm not sure what it is we've said that they don't agree with, but maybe if they can tell us, we might be able to shed some more light on it. You never get plastic gas ever. Not plastic gas, but plastic gas pipes. Perhaps that's what that engineer's referring to. Okay. Did you have another question from a previous session, Mark, to go through? Because once again we're rattling out of time.
Yeah, I did. It was a question that we've been asked kind of recently. Is I've been asked to install the electrical supply circuit for a safety service involving a water sprinkler system. Can I use standard PVC cables? So, although there is a section in BS 7671, it's chapter 56, that provides us with some answers. In particular, regulation set 560.7 and 560.8. 560.7.1 states that where the recommendations of other safety standards apply, circuits of safety services shall be independent of other circuits. Now, that kind of goes some way to answering the question. The note under the above regulation says that any electrical fault or intervention or modification in one system must not affect the correct functioning of the other. So again, we're a little bit further forward, but the regulation that kind of nails it really is 560.8.1, because that provides a list of appropriate cables that can be used, or wiring systems that can be used, shall we say. And we've got an obvious one in there, which is mineral insulated cables. There's a second example that I can use of fire resisting cables. They'll give you the British standards, so obviously your mineral insulated cables are BSEN 60702-1, the 60702-2 as well. That relates to the actual construction of the cable itself, but then on top of that it says things like that they should be tested to 60332-1 or 60331-1, for example. Now the 60331-1s and the 60332s, they are tests, they're fire resistance tests of those cables, and I believe the 60331-3 is for an 830 degrees C fire test on cables related to cables in enclosures. So BS 7671 does, can specify those cables, but on top of that, you'd need to look in the British standard for fire sprinklers regarding details for, the configuration of the electrical supply, for example. So BS 9251 will give you a lot more detail on how you would split out those circuits for things like where you've got twin pumps in use, and you might need a safety a backup supply as well. So there you have it. Chapter 56, regs 560.7 and 560.8. They're both the regulation sets. Have a look in there, and you'll be able to work that one out. 560.8 gives you the actual list of recommended fire cables.
Yeah, and just on a slightly related, there's a few questions coming towards the end about is it now a requirement to install metal conduit and nothing plastic above fire exits in the new amendment? Well, the 18th edition actually enhanced the requirements to prevent premature collapse of wiring systems. Although it doesn't specify you have to use metal conduit, you can't use plastic conduit, you can't use plastic clips to support them. You do now need to have the cable supported through metal containment of some form. Doesn't have to be trunking. You can get cable bands now that you can actually use with cable with plastic trunking, so we can't rely on anything plastic, and the intent of that regulation, which was introduced in the 18th, is all around protecting premature collapse to ensure that people are able to exit safely from the building, and also firefighters are able to enter safely. So it's a situation around providing that exit and entrance safely. That's where we need to think about protecting our wiring systems against premature collapse. Just very quickly, we just want to give you a little bit of an update. As we said, we know that Amendment 2 is coming. 28th of March is the publication date, so it is literally 4 weeks today. We're going to be running a number of different events in a number of different formats. To mark, we've got some live webinars, I believe, on the Monday morning and also in the Wednesday of that week. So that's the 28th of March and the 30th of March. During that whole week as well, we've got a number of local meets in the early evening going on, something like 30 venues throughout the country, from Newquay down in the southwest up to Inverness in the north, and also across in Northern Ireland. So go onto the website and see where your nearest local event is taking place. And as well as the live webinars, we will also be producing some on-demand webinars regarding the changes that are going to be coming in as part of Amendment 2. So please go onto the website to get some more information on those events and to register your interest for them. Once again, Mark, crazy quickness. It is always the quickest 45 minutes of the week, unbelievably. So that's the first one for a little while. We will be back again in a fortnight's time, just before the introduction of Amendment 2. So yeah, please keep your questions coming, and as I say, any that we didn't get round to answering tonight, we will try and sweep up at the start of the next one. Thank you very much for posting the questions and taking part. If we haven't answered, I still can't see a sign where the engineer that said he didn't agree perhaps needs to give us a little bit more, and we'll try and expand on what we've said on whatever the issue was. And so with that, it's good night for me, and as they used to say on the Two Ronnies, I suppose, good night from yourself, Mark. Any closing remarks you want to say? No,
I just wanted to add a bit about the little formula that we put up for transposing ZS. Is that for the bigger sort of moulded case circuit breakers, you still need to know the IA. But you could add sort of a tolerance by, UO times Cmin times a tolerance of 10% or 20% divided by IA will give you that safety margin for the much bigger moulded case circuit breakers. And of course, you can apply that to RCDs, and you would need to use the tripping current of the RCD as your IA. So just a couple of little bits there, really.
Yeah. No, and it's good to know, because once you know how those values in tables 41.2 and 41.3 have been arrived at, it's very useful to know, because you can then calculate them yourself, so that you don't need to dive into the regs book to actually get the maximum ZS values. They are, they're fixed calculations with fixed characteristics. Once you know the rating of the protective device and whether it's a type B, C or D breaker, you can calculate the maximum ZS, so long as you know your supply voltage. So it's a useful trick to know, definitely.
Yeah.
Okay, well, without any further ado, thank you very much. Once again, thanks to all of those who have posted questions and answers in. Apologies if we didn't get round to your question, but we will try and sweep it up at the start of next time. And as I say, if you are interested in the Amendment 2 events, then please go onto the website, have a look in the area for Amendment 2, and see what you can get involved with. Thank you very much.
Thank you.